Welcome to episode 04 of CipherVibe's end-to-end cloud security architecture course. Machine identities let applications, compute instances, pipelines, and automation call cloud services without borrowing human credentials. Their scale and persistence make them a high-value control surface. We will connect its purpose, design boundaries, implementation path, failure modes, and evidence of effectiveness. Every cloud security layer relies on the ones around it. They implement authorization for workloads and integrate with secrets, runtime security, pipelines, API gateways, and monitoring. A service identity should express one workload purpose rather than becoming a shared technical superuser. Treat the architecture as a chain. A trusted identity requests an action, a policy makes a decision, a workload or data service enforces it, and telemetry records enough context to investigate later. The first building block is use workload-native identities. Use managed identities, instance profiles, workload identity federation, or service accounts that obtain short-lived credentials from the platform. This reduces key distribution, makes revocation practical, and gives policies a specific workload principle to evaluate. The second building block is scope each identity to a purpose. Create a distinct identity for each workload or automation purpose. Limit its actions to exact resources, separate development from production, and prevent a build, application, or remediation job from assuming unrelated administrative roles merely because a single shared account is convenient. The third building block is control federated trust. When pipelines or external platforms exchange identity tokens for cloud access, validate the issuer, audience, subject, repository or workload claim, and environment. Avoid broad trust policies that accept any token from a vendor or any branch from a source repository. The fourth building block is rotate the secrets you still need. Some integrations still require API keys, certificates, or client secrets. Store them in a managed secret service, issue them narrowly, rotate automatically where possible, prevent logging, scan repositories and artifacts for exposure, and rehearse emergency replacement. Use this reference pattern. Begin with an explicit policy that describes the permitted outcome. Enforce that policy at the closest reliable control point. Route decision and activity evidence to protected storage. Then give an accountable team a tested path to review exceptions, correct drift, and respond to violations. The durable pattern is a workload-specific principle that receives short-lived credentials at runtime, calls only the services it needs, and has every fallback secret inventoried and rotated. Implement this layer in a sequence that preserves evidence and limits blast radius. First, inventory service accounts, keys, roles, and token issuers second. Replace embedded credentials with workload-native identity third. Right-size permissions by application function and environment fourth. Harden federation claims and short token lifetimes fifth. Rotate remaining static secrets and test emergency replacement. Prefer pilots with a named owner and rollback plan over an unmeasured organization-wide switch. The best rollout is one where a normal workflow succeeds, an unsafe path fails closed, and the team can explain the decision from logs rather than intuition. Security architecture fails most often through assumptions, not dramatic movie-style attacks. First, using a shared service account across unrelated applications second, granting a compute role broad account administration third, trusting every workflow from an external CI provider fourth, leaving API keys in images, source history, logs, or developer machines. A configuration screen is not assurance. Collect evidence that the intended control applies to the correct scope and that violations become visible. First, measure long-lived credential age and workload identity adoption second, test role assumption with valid and invalid claims third, alert on new keys, unused identities, abnormal use, and permission expansion fourth. Run a controlled secret rotation and confirm applications recover safely test both normal activity and a safe negative case in an authorized environment. Record the expected decision, the evidence location, the owner who reviews exceptions, and the rollback method. Repeat after platform changes, new integrations, or major shifts in business use. For a practical exercise, replace a fictional deployment script credential with a workload identity that is limited to one environment and one deployment action. Use synthetic information or an environment you own or are explicitly authorized to administer. Deliver a one-page diagram, a concise control statement, a list of expected audit events, and one test for an allowed path plus one test for a denied path. This artifact is more valuable than a screenshot because it explains the reasoning behind the configuration. Before scaling this layer, ask 5 review questions. Which assets, identities, or environments are in scope? Who owns the desired state and exception decisions? Which enforcement point can reliably apply the rule? Which records prove the decision and retain enough context for an investigation? And how can the organization revoke access, contain impact, or roll back safely when a control fails? Good architecture makes these answers explicit and testable. The key lesson is that machine and service identities becomes dependable only when design, policy, enforcement, evidence, and ownership move together. Document the decisions you make, remove permissions and exposure that do not support a real requirement, and rehearse the paths that matter before an incident forces the lesson. Continue through the next episode to connect this control layer to the rest of the CipherVibe cloud security architecture.